Practice test 2, calculator section, question 23. So let's get started. So both of these questions talk about this information given here. So yeah. So if you didn't get question 23 correct, that probably means you didn't fully understand the information you're given. So it's probably better to watch the explanation video for question 22 as well, because that's going to help us for question 23. So usually, I mean, it doesn't always, but it kind of relates to each other because you need to understand what's given here and apply it or use that somehow to calculate the answer. So yeah. So for the same signal emitted by radio antenna, observer A measures its intensity to be 16 times the intensity measured by observer B. So from here, we already know that it's talking about the intensity, not the other distance or the signal P or whatever. It's talking about intensity. So that's very important keyword. The distance of observer A from the radio antenna is what fraction of the distance of observer B from the radio antenna. So we're given the intensity and also, but the question is asking, right? The final question is a distance. So keep that in mind as well. So the distance is represented with letter R. So we already solved for that. I mean, at least partially. So you need to get question 22 correct, or you can like work on it, but you'll basically do the same steps, right? So we're going to use that P over 4 pi I. And you need to know that R represents the radio antenna, I represents the intensity, and P is the power. And it's written in question 2, it's written so that it's R squared, meaning it's not the distance yet. It's not the expression for the distance yet. You need to have the whole like square root on it or like in it if you want to calculate for the distance. But then observer A, so this is going to be our basic expression for the distance. But that's not what we're trying to look for. We're trying to look for the fraction. So the ratio of the two observers. So we know that observer A observer A intensity, so this I right here, is 16 times the intensity measured by observer B. So first we need to write that in 16I. Okay, so 16 times the intensity. So this is the intensity for observer B. So it's 16 times that. So it's going to be 16I. But we're not finished yet. We need to know the distance fraction. So basically what it's asking for is what's really different about these two expressions. What's different about observer A and observer B? And the key thing here is that you would want to isolate whatever you modify to the original expression. So we know that this whole thing is the original expression, right? So what did we add? Well, we added 16I, right? Which accounts for the intensity. So we just need to get that at the front of the expression so that you can see what's actually being changed. So 16i is currently inside of the square root, so we need to take that out. So when we break this apart, right, this p over 4 pi 16i apart, it's going to look something like this. P over 4 pi, and I would personally write it like this, but it's going to be 1 over 16i, okay? So from there, we know that to get this 1 over 16i out of the square root, since it's a perfect square, we can just, all right, let's move that. Oh no. Up there, and then we know that's 1 over 4 square root p over 4 pi. So from here, we know that the original expression matches, right? So I just put that aside, and I took out the number we modified, which is 1 over 16i. So it's going to be 1 over 4. So that's the thing we changed. We just times the whole original expression by 1 over 4 intensity. And that's the only difference between observer A and observer B. And what makes the answer? It's 1 over 4, I think. Yep, we're right. 1 over 4. So key thing is to put 1 over 4 at the beginning. Yep.